Hello and welcome to our 4-part Ableton live tutorial. We're going to make a track from scratch using a variety of synthesis techniques using native plugins in Ableton. We will also build a multi-sampler, non-linear sequencer and creative racks as a brief description. We have set up a voiceover track that is our vocal voiceover. So to begin, we're going to start in the session view. In Ableton, there are two windows. Firstly, the arrangement view and the session view. The session view is similar to a mix view in regards to other DAWs, except that it includes a non-linear way of sequencing clips. We will be demonstrating how to write a song using the session view. Within the session view, you can insert MIDI tracks, audio tracks, and return tracks. Moving on to clips. Clips are individual cells within a track that can contain either MIDI information or audio within Ableton. Only one clip per track can be played at a time. A scene, which is a horizontal row of clips, can only be triggered one at a time. Now, setup basics. The global quantization, which is up the top left-hand corner, also known as clip quantization, lets you adjust an onset timing correction for clip triggering. In our example, we're setting it to quarter notes. When triggering clips and scenes in session view, it starts on the next quarter note grid value. And we're going to set our global tempo to 120 beats per minute.
Cool. So to start off with, we're going to set up our return tracks. So the first one's going to be a reverb, which we're just going to have as the standard setup. We're going to engage the low cut on the reverb at 4 kilohertz. And we're going to set the dry wet to 100%, which we just did, and leave everything else as standard. The next return track is going to be a delay. So we're going to get the standard plugin from Ableton, and we're going to have that as a half note delay time. And we're also going to set the filter to 5 kilohertz, the width, also known as the Q, to 4.3, and the feedback to 15%. We're going to do another delay return. And we're going to insert a delay on this one, and we're going to change this to 3 quarter notes on the left, 6 on the right, feedback to 15%. We're going to select ping pong, put the filter to 1 kilohertz, and the width to 3.3. Cool. We're going to make one more delay return. Inserting another delay, and for this one we're going to have the left delay time at 5 quarter notes. The right we're going to change to time, and we're going to type in 30 milliseconds, and this is going to be a Haas effect for stereo width in our track. We're going to set the feedback to 15%, the filter to 1.9 kilohertz, and the width to 2.6. Next up, we're going to create our first MIDI track and MIDI clip. So we insert a MIDI clip, MIDI track and a MIDI clip by double-clicking on the first cell. We're going to change the loop length to 4 bars, and we're going to insert some notes with the first 2 bars of A minor and the second of D7. So to start off with, we double click on the A2 to create a 4-bar length note, and then we're going to have a C2 for 2 bars and an E2 for 2 bars. So that's our A minor for the first 2 bars. For the second, we're going to do a D2 and an F sharp 2. And that's going to be for the last 2 bars. We'll just drag that over. and then we're going to have one A3 at the top, an octave up. There we go. Cool. Now we're going to start with our synthesis. The first thing we want to do is set up a frequency modulation style pad. We're going to insert an operator. Now we're going to bear in mind that frequency modulation synthesis involves at least 2 oscillators, a carrier signal being modulated by another signal, sometimes more. So we're going to set oscillator 1, which is our carrier, to a sawtooth 32. That's the type of waveform. We're going to change the level of that, well, we're going to keep the level of that to -12. Our second oscillator, we're going to change to a sine 8-bit. We're going to fine tune that 8 cents. And then our oscillator 3, we're going to set to a sine. Oh, the level of oscillator 2, we need to increase it to -16 decibels. Yeah, our second oscillator is a sine with the level at -10 decibels and fine tuned to 8 cents. Next up, we're going to engage our filter to set it to 550 Hertz. The resonance at 20%. We're going to set the filter envelope value to 95%. We're going to set the attack of the filter to 1.6 seconds. The decay time to 400 milliseconds. There we go. 400 milliseconds decay time, and the release is 200 milliseconds. Cool. Next up, we want to insert an EQ3 audio effect, and we're going to cut the lows out of that to make space for our bass later on. We're going to set the value of the low cut to 200 Hertz. Next up, to create some movement, we're going to insert an auto filter. We're going to set the filter to 2.7 kilohertz, the resonance at 40%, and we're going to engage the quantization to 8 bars. Now let's have a little listen.
Alright, moving on now to subtractive synthesis. We're going to be doing a stab. Subtractive synthesis involves filtering a combination of oscillators to sculpt harmonic content. So we want to insert a new MIDI track and copy the MIDI clip over. Okay. And then we want to insert analog on there, just the stock analog.
That's right.
And on oscillator 1, we're going to want a sine wave and an octave up. And we want the filter frequency on 250 Hertz with a res of 50%. Right. Now on oscillator 2, we're going to want a saw wave and an octave down on this one with a semi +7, which is a 5th order harmonic, with the filter frequency at 600 Hertz. And a resolution of 90%. Resonance. And then amp 1, we're going to have -6 dB.
Engage amp 2. Yep.
Okay. Now we want to insert an arpeggiator now. Standard arpeggiator. Okay. And we want to insert an auto filter with the filter at 1.2 kilohertz. And the res at 40%, with a rate of 0.05 Hertz. 0.05. And then we're going to want to quantize that 6 bars with an amount of 20. Perfect. Okay, moving on now. Analog stab. Cool.
Yeah. Let's have a listen. So that's what we've just created, and if we want to listen to both, we can hit the scene launch. There they are, both there.
Okay, moving on now to a wavetable baseline. This involves a cyclical bank of waves as the oscillator module. So we're going to want a new MIDI track and copy over the MIDI clip, just like we did earlier. Wavetable baseline. And we're going to want to insert a wavetable. Like so. And we're going to want filter frequency at 2.7 kilohertz and the res at 50%. In order to control oscillator 1's wave position, we're going to need to insert a max LFO. Like so. And we're going to want to map to oscillator 1's wave position with a rate of 0.1 hertz and a depth of 35%. Alright, then we're going to want to insert an arpeggiator. With a style of con and div, with a rate of 1/8 notes, and a gate of 60%. And we're going to want the distance on -12 st. Alright. Now we're going to want to
insert.
Let's have a listen to that. Let's have a listen.
Let's insert the compressor.
Yeah. We're going to want a threshold of -15 dB and +2 dB gain. And now we can have a listen.
So let's listen to them all together with the scene launch. Cool. So we can stop that with the global stop over there in the corner. Now, next up we're going to do physical modeling, and we're going to do special effects for this particular sound that we want to create. So physical modeling involves digitally modeling real-world physical sounds and involves an exciter and a resonator. So in our new MIDI track, we're going to copy over our MIDI clip. We're going to insert the collision instrument. We're going to set the mallet section to -6 decibels. We're going to go to resonator 1 and set that to a string. We're going to put the material to -10 decibels. We're going to set the decay to 100 milliseconds and the brightness to 68%. We're going to also set the listening on the left-hand side to 42%. Now at this point, we're going to increase the delay returns to maximum. So B, C, and D to maximum, and the reverb return, which is the A, to -13, which is at about the 2 o'clock position. Now at this point, let's have a little listen to what we've got. Nice. So let's have a listen to all of them with the scene launch there. And we're going to increase the reverb and delay returns. And you can hear what we're doing as we do them. One last thing was to insert the arpeggiator onto the collision effect there. We want that to be up and down as the style, and we'll set the rate to 1/2. Cool. Let's add a little bit of reverb to our pad, some delay, and something similar with our stab. Oh no, we're all good. Right, thanks for that, guys. We'll see you in our next video.
Thank you.